All right. So these are going to be my notes on 1.1.1. Again, you guys know where all the extra supplies are. If you need more paper, you guys know where it is. Right over yonder. No, you do not need graph paper. No. Line paper is fine for this. Is this a right now question or can it wait? Okay. Let's focus right now on function machines. So I'm not putting this in my packet, but rather in my notes. So I see several of you have a spiral bound notebook. That's awesome. I love that. You're going to be happy to have that. That's a great way to keep organized in this class because I will mostly be checking your homework for completion. So you can put your notes and your homework right in the same spot. I also love those composition notebooks. Is that one that's got like the grid paper on it too? I like the red. Usually those are just like a speckly black and white. That's cool. That's really neat. Those work super well for taking notes, and too, you'll be happy to have that. All right, so we're going to talk just briefly about what's called a function machine. Have you guys heard of functions before? No. Okay. So let me show you what this is going to look like. So we're going to talk about this. I want you to imagine a machine in a factory. Okay. So this is a big metal box in a factory someplace, and it does something. And this is our machine. We're gonna call it a function. Function machines are going to have a spot for something to go in and a spot for something to come out. I just heard a light bulb turn on for somebody. You have seen these before, right? Anybody know what we call the thing that goes in? It's an input. And if the input goes in, what do you suppose comes out? Output. Nice. Can anybody think of an example of an actual machine that kind of works like this, where you put something in and something else comes out? What are you thinking of? What do you think? Oh, nice. So you're describing a kind of complicated function where you're putting like a mixture of recycled food and stuff in and outcomes, and it kind of sorts it into food. And oh, I'd like to see that. That sounds pretty cool. Cool. What else are you thinking of? Cloudy with a chance of meatballs. Nice. Yeah, yeah, yeah. Awesome. What else? Yeah, yeah, like that. Like a what? Beef grinder? Oh yeah. Cow goes in, hamburger comes out. No, 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 but yeah. What else? Vending machine. What a yeah, that's awesome. Actually, we are going to do a whole lesson on vending machines later on in this chapter when we talk about the definition of function. Yeah, but vending machine, you put some money in and a soda or a candy bar or something comes out. Cool. All right, so we're going to look at basic function machines today from a mathematical standpoint, of course. So I'm going to give you a couple examples and we're going to work through it. And I'm going to tell you that some of you, we had this conversation last Thursday. Some of you are going to be able to do a lot of this in your head. But I'm going to show you some work that I want you to be able to show as well. So let's look at an example of a function machine. The first one we're going to do, look at my notes here. So go ahead and draw me a box. We're going to put an equation in here. Y equals, and let's go 3x plus 1 for our first one. So that's our machine. We're going to have an input and an output. And for this first problem, I'm going to tell you what the input is. And I'm going to ask you to find the output, y equals blank. And this is really the big learning goal for today. Okay, this is kind of the key piece I want you to walk away from today. If I look at our learning targets on the front of our packet, the big one is the one in the middle, and that's evaluate a function for a given input. That is the key thing. So if you guys can walk out of here and feel confident doing a problem just like this, then you have met that learning target. So let's work our way through this, and I'd like to show you how you would show work for this. Now, some of you might be able to do this entirely in your head and come up with an answer. I want to show you my minimum step for this. Okay. So what I'm going to ask you to do is rewrite this equation, but leave the x out and put a parentheses in its place. Y equals 3x plus 1. Off to the side, rewrite that equation, leaving the x out, leaving a parentheses in its place. And that parentheses is blank right now because we are going to replace that x with a value. And that value is -1. Excellent. So that's our input is -1. So I've replaced the x with a -1. Now, if you are a minimum work shower, all right, and I'm going to say, Corbin, it seems like you are one of those folks. I need you to show me this. This is your minimum step right here, okay? Put a star next to it. That's awesome. Now, I like to show all of my steps, so I'm going to go ahead and do my steps to finish this. This is multiplication and addition. Which one comes first, the multiplication or addition? Multiplication first. What is 3 times -1? That's -3. We'll bring down the +1 and we'll deal with that in our second step. -3 plus 1 is, so I lost $3, got 1 back. I'm still down $2, so -2. And my final answer is -2. All right, that is our key learning target for today. If I give you an input and a function, can you evaluate what the output of that function would be? Let's look at a couple more examples here and see how we're moving toward that target. So any questions about that first one? All right, example number 2. Let's stick with the same function with a different input this time. Let's say we put 20 in as our input. So x equals 20 as our input, and we're going to try and find our output. So I want everybody to at least show me that minimum first step. That minimum first step is to rewrite your equation, just leaving out the x and replacing it with the input. Your choice if you want to show me the next couple steps or not, but at least show me this and then get me to your final answer. I'm going to show all my steps because I like steps. Three times 20 is 60. And we still have that +1 to deal with. 60 plus 1 is 61. All right, that is our key learning target right there. Could you guys show me on your thumb meters how you're feeling about that first learning target or the key learning target? So my thumb meter goes like this. Straight down means I've never seen it. I have 0 confidence. Straight up is like, give me a test tomorrow and I'll ace it. In the middle is kind of like, okay, I kind of understand the basics, but I feel like I need some more practice or maybe to ask a couple questions. And then you can kind of go in between there. Where are you guys at right now on this learning target? If I give you an input value and a function equation, can you evaluate and come out to where we're at there? I'm hoping for kind of in this middle range here is where I'm thinking most people are going to be. Some of you are super confident. That's good. All right. So I'm going to start giving you some tougher ones because I know you can handle it. Okay. And a lot of times the tougher ones, once we work through some of those, then these more basic ones, you'll gain a lot more confidence with. So let's try this. I am going to give you, let's stick with the same function. And this time around, I'm going to give you the output. And I'm going to ask you to find the input for me. Now this is a little tricky and we'll probably be mostly using guess and check here. But my output is going to be -11 and I would like you to find me and input here. This is a pretty tricky problem. We're getting into kind of more chapter 2 level here. So if we're not confident on this, that's okay. This is not our main learning target for today. All right. If you're not sure what to do, just take some guesses. Just kind of make a guess and then put it in and see if it works. If I were doing this, I'd probably be doing a lot of guessing and checking. For those who are looking at this, can anybody give me a hint about this number without actually giving me the number? Give me something that's true about this number, but don't actually give me the number. What do you got? It is a negative number. And were you able to tell it was going to be a negative before you even started? Because the output's a negative and everything here is a positive. So we must have something negative going on in our input. So it is going to be a negative number. So if you haven't tried a negative yet, go ahead and give it a shot. I will tell you it is an integer value, meaning it's a whole number. A negative. All right, I'm going to ask a strange question right now. Can somebody tell me a number that they tried that did not work? Can somebody tell me a wrong answer that they tried on the way to coming up with the right answer? Negative 14. I'm going to check negative 14. So if I plugged in negative 14, it would be y equals 3 times negative 14 plus 1. 3 times negative 14 is negative 42 plus 1. Negative 42 plus 1 is negative 41, and that does not work because it's not negative 11. All right, can somebody tell me what they think the right answer is? You think you found it? Negative 4, did anybody else come up with negative 4? Let's try it. If you haven't written negative 4 down, go ahead and check with me right now. Y equals 3x plus 1. I'm going to replace the x with, excuse me, negative 4. 3 times negative 4 is negative 12. Negative 12 plus 1 is y equals a negative 11. Check. Happy face. Done. This is a y, supposedly. All right. Any questions here before we go on to another super fun one? Yes.
Anyone else kind of reverse engineer it?
Reverse engineer it. I love that term. Can you tell me how you reverse engineered this?
I kind of just put the negative 11 back in the equation.
I love it. Okay.
Yeah, and plus would be negative 1, which would put that back in negative 12, and then divided it by 3.
Fantastic. I love it. So you were thinking about undoing these things. Now, the piece that really made my heart grow 3 sizes bigger when you said just a second ago, guys, don't miss this, by the way, because this is going to help you with our learning target, even though this is not part of our learning target. I love that you said, take this negative 11 and put it into this equation, because that's what we did when we knew what x was, right? If I put negative 11 into this equation, we get the equation negative 11 equals 3x plus 1. If I get given you this equation and asked you to solve it, how would you have solved it? Well, you would have done the exact same 2 steps that you just told me, right? You would subtract 1 on both sides to get negative 12 equals 3x. And then how would you get rid of that 3? You would divide by 3 on both sides and to get negative 4. Did anybody do it that way? Did anybody actually set up an equation and solve it that way? Couple people over here did. That's cool. That's cool. That's way ahead of the game right now. So if you didn't think about doing this, that's okay, because we're going to do it later on. I want to try one. What time we got here? Oh, you guys are doing such a good job. I'm gonna throw 2 more problems at you. Okay. One of them's pretty important, and the other one's another just for fun, tough one. All right, this one's kind of important. This is one of our lesser learning targets today. I'm going to give you an input. Our input is going to be -2. And it is going to go into this same function. But rather than just taking the output from that, I'm going to take this machine and I'm going to hook it up to another machine. And I'm going to ask you to find the output of that. So I got two machines hooked up end to end. I'm going to put -2 into the first machine, and then that's going to, whatever the output for that is going to pop out and it's going to go is the input for the second machine. And then you're going to tell me what's going to come out at the end of that. And this is really what a lot more like what a factory actually looks like, right? There's usually not just one machine. You got multiple machines that are kind of hooked together to make an end product, right? So you talked about the beef thing, right? If we thought about a factory, and a machine would be like a room in the factory, like you'd have your slaughtering room where they're actually pulling apart the cuts of the beef, right? That would be so the cow comes in, the cuts come out, and then the cuts go into the machine with the grinder, and then the hamburgers come out of that too. That's kind of what we're doing here, and this is what's called a composite function. So see what you can do with this. Is anybody willing to share a strategy? I don't want an answer. I'm not looking for spoilers. I'm just looking for a strategy here. Is anybody willing to share a strategy for those who might be a little unsure where to start here? What would you do first, Jonathan? Okay, so we're going to have to plug something in. We're going to have to replace something. Strategy, no spoilers. Ooh, so you're saying that this is kind of a key piece right here is what are we going to get at that spot? And is it an X or a Y? It's actually kind of both, isn't it? It would be Y equals, and then it would turn into an X when it goes in. At any rate, we need to know what number is coming out of this and going into this. I love it. I love it. All right. So if I were doing this, my work would be Y equals 3X plus 1. And I'm putting in -2. So that's what's coming out of the first machine. And then what do we do with that -5? Say again. So, and then that is because that's a great question. So the question is, does this -5 go in for X or Y here? What do you guys think? X. The input is typically going to be the X. It's going into that second machine, so we want it to go into X. That's yes. So it's a Y coming out of this, but it becomes an X when it goes into this, which is a little bit tricky about it. We are going to end up with a -10 and then a -4 to it. They're not multiplying. Yes, you are correct. We are going to have a -10 in there. Hang on, let me catch up to you here. So we'll put that -5 in there. So I'm seeing where you get the -10 from. But it's -10 minus 4. If I wanted to do -10 times -4, I need to put parentheses around that -4 like that. It would be -14. Yeah. Awesome. All right. One last one, and this is a tricky one. And I'm going to pass out your assignment while we're working on this one. All right. Let's see what you guys come up for this. So we were just talking about absolute values. And I threw it away. There it is. No, it isn't. I'll have to make up a new one. That's okay. This is going to be one of those ones where I ask you for the input. I'm going to tell you the outputs. My function machine is Y equals the absolute value of X minus 5. And my output is, this is an absolute value of X minus 5. And my output is 2. See what you can do with that. All right, again, this is a higher level than we really need to be at today, but I wanted to give us a chance to practice with absolute value. Can someone give me one input that would result here? One input. I'm looking for someone I haven't heard from yet today. He's gonna be brave. Thank you. 7. Let me try 7. So y equals the absolute value of 7 minus 5. 7 minus 5 is 2. So I've got the absolute value of 2, which is 2. Beautiful. That works. There is another input that would also give you an output of 2, and that number is 3. Let's try 3. Y equals the absolute value of x minus 5. We're going to try putting 3 in here. Help me out. What is 3 minus 5? -2. That goes in our absolute value, though. And when we take the absolute value of -2, we're going to get 2. So if you're able to come up with one of those answers, 7 or 3, I am super impressed. If you came up with both of them, that is awesome. All right, we're going to switch gears here and talk about the assignments. So let me turn off my recording here. Let me get